Old technology still works. Okay, today what we're going to do something called the grouping method, but we're going to build our way up to the grouping method. You'll remember last week before you left, we started doing something called factoring. Factoring is unmultiplying things. Right? We started it off with having things like, you don't need to write this down, but we had something like 4. By the way. There we go. You had questions like this. There's like 4x plus 6x squared. And we would say something like, take the greatest common factor out of it, right? We call it removing a greatest common factor. It's the first type of factoring that we learned. To remove a greatest common factor, what you did was you tried to find the biggest number and the biggest letter that would divide into all of your terms, right? So our terms were 4x and 6x squared. If you looked at each of those numbers, they could divide by 2, and they could divide by x. And 2 is the biggest number that divides into 4 and 6. X is the biggest letter that could come out of x and x squared. That was called our GCF. We then would have a remainder when we divided our terms by 2x. When we did 4x divided by 2x, the remainder was 2. When you did 6x squared divided by 2x, you had plus 3x. And that's just a review of what we did before the weekend, right? That's called removing a greatest common factor. Kind of ring a bell? Somewhat? Yeah. We're going to do the same thing today, just a little different. It's going to look a little strange. Okay, we're going to start off by removing the polynomial greatest common factors. So if we look at class example 1, if I said remove a greatest common factor from this question, you would have to view this as the first term and this as the second term. Right? Terms are separated by positive or negative symbols, so this minus sign is separating the two terms. Looks kind of strange, right? We normally wouldn't talk about it like that. Like you have a polynomial inside of this red term, and you have another polynomial inside of this purple term, so it looks a little strange. So if we looked at that and we said, I want you to remove a greatest common factor from the purple side and from the red side, is there something they both have in common? So when you look at the red term over here, purple term over here, do they both share something?
Positive 7.
Yeah, they both share a positive 7. In fact, they both share, I wanted blue. They both share an x plus 7. See how those are both the same thing? That means I could take a GCF of x plus 7 away from the red side and from the purple side. So I'm going to take that x plus 7, I'm going to take it as a GCF so it comes out front. And then I end up with a remainder after I take a GCF out, right? The remainder is what's left over when you divide each polynomial or each term by your greatest common factor. So if you're looking at the red side and I divide by x plus 7, then the x plus 7's cancel out and I'm left with 4x. And that's the only thing left on that red side. On the purple side, if I divide out x plus 7, all I'm left with is a minus 3. When you remove a greatest common factor from a weird looking polynomial like that, this is your solution. You have x plus 7, 4x minus 3. You get two binomials multiplied together, which was usually our goal, right? Looks weird the first time. We're going to do it like 6 times together, so you get lots of practice. Okay, so if you look at B, we look at that thing. I like to break it into sides. So this is my red side. This is my purple side. I ask myself, is there something they both have in common? They both have a 3 minus 2y in common. And you see that 3 minus 2y there, 3 minus 2y there. When I take that as the GCF out, so I'm taking out that entire binomial, I'm left with a 7 from the red side and a positive 2y from the purple side. That's my solution. I've unmultiplied this thing, right? All right, we'll try one more together. So we have, again, I like to break it into two sides. We have the red side, we have the purple side. I try to figure out what both those things have in common. The red side has a 4a plus 1. The purple side has a 4a plus 1, right? They have the same binomial. So I take that same binomial and I put it out front. 4a plus 1. When I remove that greatest common factor out, on the red side, I'm left with 9a. And remember, our remainder goes in a set of brackets. From the purple side, I'm not left with anything, right? It completely canceled out when I divided it out. And remember when we did GCF last week, we said that it doesn't completely cancel out. There's something left over. What do we put when it completely cancels out when we remove it? Yeah, it's a plus 1. Makes sense. That would be completely factored by removing the greatest common factor. Awesome. There's 4 questions down there. I want you to try A and B. Then I'll do C and D with you because they're a little bit different. A little bit of a trick to C and D. If you want to try them, feel free. But you'll notice that they're a little different when you try them. Okay, so give A and B a shot. See if you can back for those. So, if you look at A, the 2 terms here, there's one there, that's one side, this the other side. And it's just on those sides, there's even more terms, right? So it's a little bit complex when you first look at it. But these are separated by the plus sign. That's what makes this a binomial, or how we kind of look at it as a binomial. On each side, there should be something they both have in common. In this case, they each have a 3y plus 2. So the 3y plus 2 is my greatest common factor. It's the biggest thing I could have taken out of both of them. On the red side, when I divide out a 3y plus 2, I'm left with a 5y plus 1. And on the purple side, sorry, I didn't want to put a bracket to close off that red side, and that's how it's all going to erase. On the purple side, I'm left with a plus 4y. This one's a little different than anything we've done before because when I took out my binomial, I was left with another binomial, right? 5y plus 1. The other ones were all monomials. If you look inside the brackets, we have like terms inside my remainder brackets. There's a 5y and a 4y, so I could combine those to be 9y. Right? My final answer would be 3y plus 2. 9y plus 1. That would be my final answer. I went a little too low on the first part. All right, let's look at B. So I have my red side and my blue side, or my red side and my purple side. Like a red and purple. Right. Red and purple. They both have something in common. They both could take an A minus 6 out. When I take an A minus 6 out, I divide it on each side. I'm left with, from the red side, a 3A. And I'm left with, from the purple side, a minus 9. And there's no like terms I can combine in either of those, so that's my final answer. Awesome. C and D. So there's a problem with C and D. The problem with C and D is that the binomial that they have that is the same, it's not the same. If you look, it almost looks like they both have x minus 5, but they're reversed, right? This one's x minus 5, this one's 5 minus x. Those aren't the same binomial, so I can't remove that, right? It's not a common factor. It's really, really close, though. Right? It's almost suspiciously close, right? Almost like you could do something to make them the same. So what we need to do is somehow take the second binomial and reverse it. Right? If we could flip it completely and make it x minus 5, then we'd be set. The way you do that in math, the way you change the symbols to make it completely opposite, is you factor out a negative 1. It's the same thing like when you times by negative 1. You know how it changed all the symbols? Same idea, if you take out a timesing by negative 1, it'll change all the symbols. So if we look at this guy right here, and I take out a negative 1, it would change the 5 in front to become negative 5. And then inside the brackets reverses to be x minus 5. So you can flip them by changing the symbol in front. The other side, which I wanted to be red, not blue, would still be 2x, x minus 5. The big difference here is that I changed the symbol. Instead of it being plus 5, it's now minus 5. Right? And that allowed me to get the exact same thing, which is x minus 5 and x minus 5. Now I can treat it just like any other question. Okay, I take that x minus 5, it's my greatest common factor, it goes out front. On the red side, I'm left with 2x. On the purple side, I'm left with minus 5. Alright, if you didn't try D, look at it now and give it a shot. And you kind of have that same issue where it's x minus 3 and 3 minus x. So see if you can figure it out now. I'll give you about a minute, then I'll do it. Alright, looking at that guy. Again, our greatest common factor, x minus 3 and 3 minus x, aren't the same. Really close, but complete opposites. Okay? I need to flip one of these around. I'll flip this one around, the second one, the purple side, by changing the minus 4 to be plus 4. When I change its symbol, what I'm really doing is factoring out a negative, which flips my items inside my brackets. So it looks like that. On the red side, I didn't need to change anything. So I still have this. That's the trick, right? So when it's really close to the same, you take out a negative and flip it. What that leaves you with is the greatest common factor of x minus 3. On the red side, we have 20x. On the purple side, we were left with a plus 4. Like, not so bad, hey? All right, that trick of like taking out a binomial as a GCF is part of something called grouping method. All right, the grouping method is something that we are going to do. So I'm going to draw a little tree on the side of the board here. Won't fit on my